Hi there! In this video, we'll be showing examples on how to simplify exponents. Specifically, we will try to incorporate the laws of exponents as well as its properties in solving these problems. So let's try this first example. We have 2x squared y raised to negative 2 parenthesis, and that one is raised to negative 2. So how do we solve this one? Well, since it's PEMDAS, we start with the parenthesis first. But observe that we can't really multiply or divide anything inside this, since all of these numbers and variables have different bases. So we start with this exponent. So we apply this one. So this one would become 2 raised to, let's use a different color for this, negative 2 times x squared times negative 2 and y raised to negative 2 times negative 2. So what we used here is what we call the power of a product law. So this is what law we used here. So basically we distributed the exponent outside to each of these numbers and variables. And then we just proceed to simplifying this. First, 2 raised to negative 2 would become 1 over 2 squared. So the reason being is because of the negative exponent property. That's how we achieve that one. Then this one, we multiply it, that would give us x raised to negative 4 and y raised to 4. And then this one would become 1 over 4. This one would become 1 over x raised to 4 due to the negative exponent property again. And then just simply y raised to 4. And then we can combine all of these together, giving us with y raised to 4 all over 4x raised to 4. And this is the answer. Let's go on to our next example. We have 14 n raised to negative 10 all over 7 n raised to negative 8. So in here, what we do is we can first remove the whole numbers from the variable side. So we can write this one as 14 over 7 times n raised to negative 10 all over n raised to negative 8. Then what we can do here is, first we can simplify this one by our knowledge in fractions. And for this one, we can apply the quotient law. So this one would become 14 over 7. We can write that one as 7 times 2 over 7. And this one would become n raised to negative 10 minus negative 8. So let's put that out here. This is the quotient law. And then we can cancel out the 7s out here, giving us 2, and simplify this one is negative 10 plus 8, or that is simply n raised to negative 2. And then we just simplify this again. We simplify this through this one through negative exponent property. This one would give us 2 over n squared. And that is the answer. Let's have our third example. We have quantity 3a raised to negative 7 times 9a raised to 14. So first, through commutativity and associativity of real numbers, we can write this one as negative 3 times 9 times a raised to negative 7 times a raised to 14. 14. There. So basically, we paired out the whole numbers as well as the variables. So negative 3 times 9 would simply be negative 27. And for the variables part, we simply apply the product law. So this one would become a raised to negative 7 plus 14. So let's put that out here. Is the product law. Simplifying this would give us with negative 27 times a raised to 7. And this one is actually the final answer. Let's just erase this one and move this one to simplify things. So this is our answer for our third example. Let's have this fourth example. If we have a squared cubed times b cubed squared. So how do we solve this one? Well, what we can apply here is the idea or the law of the power of a power law. So this one would become a squared times 3 times b cubed times 2. So basically, what the power of a power law states is that we simply multiply these exponents when it's outside in a parenthesis. So let's take this one as the power of a power law. And simplifying this would give us with a 6 times b raised to 6. Now, is there still anything that we can do out here? The answer is no, since these are different bases. So we can't just multiply it. And so, this one is our answer. Let's have this one last example. We have x raised to 0 plus y raised to 5, z raised to 10, and x raised to 9. And this one, this is y raised to 1/2, and z squared. Now we put a fraction So how do we solve this? Oops, I forgot the exponent part there. So how do we solve this one? Well, first by PEMDAS, we know that we start with the parentheses. So let's put that out here. PEMDAS. So starting with the parentheses, we first note that, recall that x raised to 0, this one is simply 1 since it's a 0 exponent. So this would simply be 1, or I don't really need to put it. So this one would become y raised to 5 z raised to 10 all over x raised to 9 y raised to 1/2 z squared raised to 2. Or let's just put it so to avoid confusion. And then what we can do next is we can actually apply the quotient law in y and in z. So in the inside, this would give us with, of course, the 1 over x raised to 9, then y raised to 5 minus 1/2 times z raised to 10 minus 2. And then we simplify these exponents. Now for 5 minus 1/2, recall through your knowledge on fractions that we can actually write this one as 10 over 2 minus 1/2, since 10 over 2 is also 5. And this one would become 9/2. So this one is equal to 1 over x raised to 9 times y raised to 9 over 2 times c raised to 8 squared. And then simplifying this further, we can now apply the power of a product law. So that's basically distribute this one to all of these products. So let's set this up. Power of a product. And that would give us with, first, note that when we distribute 2 in 1 over x raised to 9, that is also like applying the power of a quotient law. So this one would become 1 squared all over x raised to 9 times 2 times y raised to 9 over 2 times 2 times z raised to 8 times 2. And then we just simplify these exponents out here. Let's use this color. So first, 1 squared is simply 1. Then 9 times 2 would give us 18. This one, we simply cancel out the 2's out here, leaving us with 9. And 8 times 2, oops, sorry about that. And 8 times 2 would give us with 60. And so the answer for this one, combining everything, would give us with y raised to 9, z raised to 16, all over x raised to 8. And this one is the answer. So that is how we simplify exponents. We use the laws and properties presented in the previous video. So as you practice more exercises in this becomes more easier, and you won't even notice that you are using the laws, since it will go really smooth in answering all these examples. And so that is all for this video.